Welcome back. We're on the final run of getting our ECS working using our Perlin noise created cubic landscape as such. Right, the last thing we need to do is to create the actual system that runs everything and that spawns all of the cubes. Now, this is going to be a job component system element. It's script that lives in the asset folder, but you don't actually put it on anything in the hierarchy, which is quite interesting and feels a little odd to begin with because you'll be so used to putting stuff in the hierarchy in order to get it to run. But because the ECS is essentially running everything in the background, kind of out of your control once it starts, you can't like select an object in the scene and then investigate it like you used to with game objects. It's just very different. Right, so let's create this script anyway. So let's create a C# file and we're going to call it a spawner system. Okay, let's open that up. Now anything that's named a system, in this case a job component system, will be something, as I said, is going to run for you automatically by Unity. So let's make this a job component system to begin with, and for this to actually function we need a whole different set of libraries at the top. So first of all we're going to using unity.burst, which is that new super fast C compiler, then using unity.collections, using unity.entities, using unity.jobs, using unity.mathematics, and using unity.transforms. Okay, so the mathematics and the transforms, you'll see those used specifically in here because we're actually going to be positioning the cubes. Now, we don't need any of this anymore because we're not working with a mono behavior. Now, the first thing we need to do is create a system or a command buffer system to put all of our entities into. Okay, so the type is end simulation entity command buffer system. Thank goodness for autocomplete. That's a big mouthful. Let's call it M entity command buffer system, which is what it is. The first method is on create manager. Okay, so this actually will create your entity manager that's going to hold on to all of the entities. So it's going to be a protected override void on create manager. Okay, we don't want the automatic base that was created for us. Inside of here, it's as simple as initializing this. So let's just grab a copy of that and we're going to say that it equals world.get or create manager, just in case one already exists, and simulate, yes, that big long word that we put in before, and brackets on the end like that. Okay, so make sure that you've got all of that in there. That's all that goes inside of your on create manager. Under here we're actually going to create a job in the form of a structure which will spawn all of our entities. Okay, so let's begin. Struct spawn job. It's going to be an I job process component data with entity. Another really long word. Imagine at some point they might cut all these down to make them a little bit shorter. Now, what we're creating is the spawner. So we created the spawner, which becomes its own entity. Okay, so currently it's a game object, then it becomes an entity. And then in here, we actually, I guess, cause it to then exist and run. And let's send it to local to world is the other parameter that we require in here. Okay, so what goes inside of spawn job? Public entity command buffer. After that, we want a public void execute, which is going to do the work for us. So execute, and it's got a whole bunch of things that need to get passed through to it. First of all, we've got entity, int index, then a read only reference to the spawner, that's which we'll call spawner, and then read only reference to local to world location. Bear with me with all of these variables properties. We're about to use them inside of this execute. Okay, so this is where our job is going to create our world. So this is the nested for loops that we've used before. Okay, so we want a for int x equals 0. X is less than the spawner. And what did we put in there? The e columns. Oops. Dot e cols. And then we want x is plus plus, like that. Now I can't remember if we use columns or rows for the x, so if we just really quickly just duck back to the original code that we wrote here, if we remember, here's our nested for loops instantiating our cubes the old way. So we used rows with x and cols with z. Now because they got the same value in them, it doesn't really matter, but let's just do the same thing. So where is it? Rows first, so let's put e rows. Okay, and then in here we will have for int z equals 0. Z is less than spawner dot e cols z plus plus. Okay, just bracket all that up. And then inside of that is where the spawning actually occurs. So it's not a lot different than what you're used to. It's just possibly a little bit foreign because of the new ECS calls and that they have. Let's just finish off that structure too while we're there to get rid of that error. Okay, so we want a var instance again. So this is like creating our game object with instantiate. But this time we have to create an entity instead. So the way we do that is our command buffer dot instantiate. So I guess it is an instantiate. Spawner dot prefab. Okay, remember we passed through our cube prefab to the spawner proxy, then passes that through to the spawner structure, and now we're actually using it. Okay, now we need a position of where to put this instance, this entity in the world. So go var pos equals, and this is a little bit different than doing our vector 3s. Okay, so the mathematics for the ECS is very familiar, but you don't use the same things as vector 3s or vector 2s, or the things that you're used to with game objects. Okay, so in this case, the position equals math.transform local.value, not local to world. Sorry, not local, it's location, because the location gets passed through here. Basically, it's saying we want it local to the world, so we're using the world coordinate system. So we're creating a transform for our entity, which is based on the world's coordinates. Okay, so that's the first value. The next thing we need is the actual position in that world space, which is going to be like a vector 3, but it's actually called a float 3 in this. So new float 3, we want to put it at x for the x value, and then we want to use our Perlin noise that we've created before, but we can't use our mathf library anymore. So we have to use the ECS provided ones, which is going to be noise, C noise. This is doing the same thing. New, we want a float 2, which is going to use x and z multiplied by 0.21f. And you remember seeing that before? Let me just put our z value in here to finish this off for position, and then we will go back and have a look where we're positioning our cubes. Back in this spawn cube, here's our position. Here's our Perlin noise in the old mathf, taking an x and a y value, or in this case x and z. So it just takes two values that are both multiplied by 0.21f, and that's what we're doing back here. We're just using the new notation of the ECS. Okay, so we've got that. Now we need to apply that transform to the entity that we've just created. So command buffer dot set component instance new translation value equals pos. Now, after this double lot of for loops, what we need to do with this particular job is to get rid of it. We only want it to run once, and if we put it into the system the way that we're about to, that you do with jobs, it will keep executing over and over and over again, which means you'll end up with lots and lots and lots of cubes all in exactly the same place, and then your whole system will just basically get bogged down because there'll be just way too much stuff going on in there. So after the for loops, what we're going to do just down in here is remove our spawn job from the command buffer. Okay, so all we do is put command buffer.destroy entity and give it the entity, which is the spawner in this case, and that will actually get rid of it and stop it running again. Okay, so that's the structure, the job that needs to run. We now actually have to make it run. So the next thing we're going to do for this particular class, this job system, is to have an on update. Now you can see it's not yet complete. It's got an error up there still, and that's because its main method, it's like its update, which is the equivalent of an update from our mono behavior. It doesn't exist, so it has to exist, and it's what gets run and then makes sure things run so that we can create an instance of this particular job, run it, and then it's gone. All right, so you with me so far? Please hang on. I mean, this is really quite abstract if you're a older Unity user, and I don't mean older by age, but I mean that you've been using Unity for a long time and you're very used to the game object system. This is very, very abstract, but I must say it is way better than it was, and I think I already said that earlier on. Okay, so let's just add this in. Just bear with me while we put this code in. So it's protected override, job handle gets returned, and it's an on update, and a job handle also gets sent to it, which means that you can keep sending through jobs for it to perform, and it will keep checking on their status, and if they're still running, then that's all right. But this is good because this gets code running in the background outside of your normal mono behavior update loop. Okay, so let's do this. It's kind of like a threaded system. It is a threaded system. So what goes inside of our job handle? Okay, so we create our job. So job equals new spawn job. So we're using our structure we created just above. Command buffer equals the M entity command buffer system dot create command buffer. Now this is again without a semicolon on the end of this because it's actually not running that line, it's constructing the job. And then we want a schedule single this input depths, which is a handle to our job. Then we want a semicolon on the end of that. Okay, so then we go M entity command buffer system dot add job handle for producer job. And if we keep passing through the job handle, the system will know how far through that job is of being run in the background. Okay, we've done it. We've made it to the end of this very abstract looking code. Let's try it out. So let's save it, go back into Unity. Now our spawner, which is going to get created and then be destroyed, needs to have our spawn proxy script on it, which it currently doesn't. So grab that spawn proxy script and drop it over there. Now it requires a cube, which is our special entity cube that we created. So this prefab, drag and drop that there. And then it needs to know the number of rows and the number of columns. So let's do 1,000 by 1,000 because that's what we really want to know about. We want to know the difference that we're going to get creating these this way than the old system. Now this will take a little time because it's generating all of those entities for us, but once it does, we can have a look at a comparison between what we've got now and what we had before. Now if you try and drop the warthog into the scene, just have a look at this. There's our warthog, and straight through and on forever, because what's happening is that those cubes do not have any physics on them whatsoever, and that's because the current physics system with the game objects is not compatible with the ECS system, and you'd have to write a new physics system, which some people have done for the ECS, but Unity are currently working on that now. So we're not going to be comparing this scene here without physics with our other one and the warthog. So let's just run this again. We won't worry about adding in the warthog, but we will go and have a look after we've created all of these cubes what the kind of stress is on our memory. Right, so once they come up, we're going to go Window, and we're going to go into the profiler and find our memory. Now you can already see just by scrolling through this what the lag's doing. It's much nicer. Let's have a look down at our mono value here, 126.4. Now from memory, I remember before the other way was actually more than double that, wasn't it? It was a lot higher. So it was taking its toll on the system. Okay, so let's just put that profile over to the side for a moment. If I grab the main camera, I can actually manipulate it in the scene. Let's just move around a bit so we can see a bit more of our scene like that, and you can just see how smoothly you can travel across the entire scene as opposed to before when we did it the old way. So Unity's ECS is the perfect example of implementing a flyweight design pattern technique, even though at the moment it's still a little bit abstract and in development. You can see the benefits of sharing data and sharing components in memory. Thanks for watching. Please support the development of more superb online learning content by subscribing, and as always, visit holistic3d.com to learn more about awesome games development books and tutorials.